Hello, welcome everyone to the second lesson of topic 3 on sustainability of water management in the agri-food sector. In this lesson, we will talk about wastewater treatment technologies and processes. The objective of this second lesson of topic 3 is to describe the main treatments and processes used for water treatments. These treatments are based on physical, chemical, and biological processes. The composition of the water has a high variability depending on its origin, so there is no single treatment for our water. To this, we must add that we need water of different quality for different uses. For all these reasons, the treatments will always depend on the quality of the water and its source, and that which is necessary for a certain use. Water treatments are classified according to the type of processes that cause the cleaning of the water. These processes can be physical, chemical, and biological. Sometimes combinations of these three are given in the same treatments. Screening has the objective of eliminating the larger components to reach a treatment plant. For example, stones, wood, plastics. Screening does not purify the water, but it protects the equipment that will carry out the treatment. Sedimentation is a simple process in which particles with a greater density than water fall to the bottom of a deposit. These particles, along with their associated contaminants, are removed from the bottom of the tank as sludge, while the cleaner water exits from the top. Flocculation is a physical process through which, thanks to slow agitation, particles that do not settle easily collide and form larger aggregates that facilitate settling, making it easier to remove them from the water. This physical process is combined with another chemical process called coagulation, which we'll describe later. Filtration is another physical process in which we can separate suspended particles from water. In filtration, the water is passed through a porous bed or filter that retains the particles and the clean water exits at the bottom. Membranes are selective barriers that allow substances to be separated from water based on their size. Its implementation in water treatment allows to improve the control of contaminants, to disinfect without adding chemicals, and allows to reduce the space necessary for water treatment in comparison with more conventional treatments such as settlers. Ultraviolet radiation allows the destruction of pathogenic organisms present in the water, such as bacteria or viruses. This is achieved by breaking the DNA chains, thus causing the death of the microorganisms. We now enter the chemical processes. The first is coagulation, which involves adding chemical reagents to the water so that very small, hard-to-settle particles called colloids can aggregate to form larger, heavier clots. As stated, the coagulation process is combined with the physical process of flocculation to obtain better results. Ion exchange consists of the use of resins that contains ions on the surface and that can be exchanged with polluting ions present in the water. This treatment manages to reduce the hardness of the water in a treatment for drinking water and also remove nutrients or metals in the case of wastewater. Chemical disinfection consists of adding disinfectant reagents to destroy pathogenic microorganisms. The most common are chlorine and ozone. Biological treatments use microorganisms to remove pollutants from water by using them as part of their metabolism. Aerobic biological processes use aerobic microorganisms which are very effective, but technologies based on them, for example activated sludge, are energy intensive. In addition, they produce a lot of sludge as waste. One option to improve the sustainability of biological processes is to use anaerobic microorganisms. That is, they not use oxygen. The advantages of these processes is that they also treat water, but they produce less sludge as waste. They are also usually already stabilized. They have lower energy consumption, they produce methane, which is fuel, and they allow us to recover useful nutrients for agriculture, such as nitrogen or phosphorus. The development of water treatment has allowed the implementation of advanced technologies. An example is the anaerobic membrane bioreactor. This treatment combines anaerobic biological processes with membrane technology, with all their advantages. These advantages are high quality of the effluent, suitable for reuse, energy production from organic matter, possibility of recovering nutrients, and more compact facilities. Constructed wetlands are an example of treatment suitable for being implemented at farm level. These systems have low investment on operating costs and allow runoff pollution to be controlled thanks to the natural processes that occur in it. In addition, they have other advantages such as increasing biodiversity and improving landscape. At the industry level, water treatment will depend on the type of agro-industry. Treatments in industries allow saving in discharge fees, which normally depend on the pollution of the water that is discharged. In addition, the treatments can integrate resource recovery criteria to reintroduce them into the production process. Anaerobic membrane bioreactors are becoming more common in the agri-food industry due to the advantages they present. Finally, treatment plants are the last step before returning the water to the environment. These plants collect all the water coming from homes, industry, and fields. Its function is to guarantee the environmental and health protection. A brief summary of all the above would be: the composition of water is highly variable depending on its source. Therefore, water treatment should be designed case by case, attending to its quality and source level and its intended use or discharge. Water treatment and associated technologies can be classified according to the nature of the process, divided into physical, chemical, and biological treatments. There are different approaches to wastewater treatment depending on whether they are produced at farm or industrial level in the agri-food sector. Constructed wetlands represent a potential option at farm level to reduce the pollutants load in agricultural runoffs. Anaerobic MBR, anaerobic membrane bioreactor technology, shows a good performance in agri-food industry since it allows organic matter valorization and resource recovery.